Hi everyone. Welcome to a brand new edition of the Build Tech Talks. My name is Sjoukje Zaal and I will be your host this evening. Tonight we are going to cover Microsoft technology again. And this evening will all be about Azure. We have two great talks that are going to focus on how you can deploy, manage and secure your Azure infrastructure. So we have two great sessions tonight about these topics. First, we have Joost, and he will start by giving us some tips and tricks on how you can secure Azure Kubernetes services. And he will focus on some options to integrate AKS with various Azure technologies to secure your clusters. Next, we have Frank van der Peet, and he will tell us how to use Terraform in Azure. He will show us how to create infrastructure as code to deploy different resources into your Azure environment. But that's not all. We also have a small contest tonight where you can win one of the awesome Build hoodies. Like this, my favorite sweater, to be honest. After the last session, that's going to be given by Frank van der Peet, we will show you a QR code that you can scan, and this will redirect you to a form where you need to answer a question which is related to the topic of the last session. And this form also includes a small survey that you need to fill in. And we will pick one winner after this tech talk. And this winner will get this awesome hoodie. So let's get started with the content now. I want to introduce our first speaker, Joost Wendt. Hi, Joost.
Good evening, Sjoukje.
Thank you for joining. How are you?
Yeah, very well, thank you. Glad to be here.
Yes, glad that you are here. You have a great session, a great topic. Can you introduce yourself a bit?
Yeah, sure. I'm a developer at Capgemini, and I'm focusing on Microsoft cloud native development. So I'm a .NET Azure guy.
Nice, nice. And what are you working on at the moment? Do you have a nice project?
Yeah, I'm currently doing quite a few integrations all around Microsoft Dynamics, but all the integrations are actually present in Azure. So I'm doing a lot of API management and logic apps, those kind of things.
Interesting. And also, you have a lot of experience with AKS, right?
Exactly. Yeah.
Okay, nice. One of your favorite services in Azure?
Yeah, it's quite an interesting thing, and I really love the way how it is integrating two different worlds, the open source Kubernetes world. So it's actually a product that came from outside, but I love the fact how it is integrated in Azure and all the Azure resources that are running their Kubernetes. So it's kind of mixing two worlds together.
Yeah, yeah. It is also one of my favorite services and a very complicated service.
Exactly.
Yeah, yeah. And you're going to focus on the security part of it. Also
Yeah.
very interesting. So the floor is yours. Good luck with your session.
Yeah. Thank you very much. Okay. Well, thank you all for joining. Today, I'm going to talk about AKS, Azure Kubernetes Services, and I'm going to focus all around security around AKS. But before we can really dig into the security components, it's important that we realize a bit what you get if you just deploy Azure Kubernetes Services. So let's see what you get if you just start with it. This is a slide actually provided by Microsoft. It gives you the reference architecture of AKS, and it contains a typical deployment, where in the left bottom you have the management capabilities of AKS. You have your Azure pipelines doing Helm upgrades or creating containers that are being pulled by Azure Kubernetes services. You have the DevOps guys maintaining your cluster, monitoring your cluster. In the center, you have your workload, and in the left top, your customer application. So this is actually a gateway to the outside world. The backend services contain your backend services in Azure that are doing the persistence. So you see a lot of components, and it's not just one single thing that you deploy to Azure. So let's take a look what you really get if you just do a next finish deployment of AKS. You'll actually get two resource groups. One is the resource group where you have deployed your Kubernetes cluster. So this actually contains Kubernetes. And you get a second resource group for free. And that contains all the other stuff that you need to run Kubernetes. How does it look like in real life? Over here, I have a Microsoft Azure environment with a resource group dedicated to this build talk. This contains Azure Kubernetes Services. This is basically the entry point. That's the left column that I've just shown in my slide. The right column is a second resource group that got created while creating your cluster. And it's always named MC underscore and then the resource group mentioned over here, and then the name of your cluster. Inside this resource group, you will get all kinds of resources required to run your workload. For example, a virtual machine skill set. This one is really tiny because I've just deployed this for this demo, but you can imagine if you do enterprise workloads that you'll get a lot of resources over here. You probably need disks to persist stuff. You get additional load balancers, more virtual machine skill sets, etc. Now, by far, the most important thing if you want to secure this entire environment is that you want to protect your API server. The API server is mentioned in the left bottom of my architecture diagram that I've shown in the start, and it contains all the components who are doing remote management of your cluster. And then let's underline remote management. If you're able to remotely control your cluster, you can also introduce remote vulnerabilities. They're even out in the open on the internet if you don't protect it. You really have to protect them because all you need to access your cluster as a DevOps guy or as a pipeline is a kubectl.config file. And the kubectl.config file is just present on your machine. So let's open up a Explorer window here. Let's go through my user profile directory. This user profile directory contains my desktop, my contacts, my documents, etc. But there is also a .cube folder over here. And this .cube folder contains a config file. If I would open a config file, I would see details like this stuff in the right bottom. This config file contains a certificate data, it contains a key, and it contains a refresh token, which is all you need to access your API server of Kubernetes Service. So if I send this file to Sjoukje, I'm lost and Sjoukje can access my cluster. I really need to have control of who can do this. There are a couple of options for that. The easiest option is to set an authorized IP range list of IP address ranges who can control that cluster. In this case, it is my own private IP address, so it's a /32 range. In case it is your office, it might be one of your outgoing IP addresses. You can even add more ranges if you have multiple offices or multiple departments who have different outgoing IP addresses. But in the end, it's still not really a controlled environment because right now I'm doing it from my home, but it still means that my daughter can access the same cluster. And if you're doing it from the office, then your entire office, all your departments who share that outgoing IP address are using the same outgoing IP address. So they are all allowed to access your cluster. So it's probably better to create an internal cluster. That's the second option. If you enable the private cluster, then not your entire cluster is internal. Your customers still have public endpoints, so you can still distribute your applications on the internet, but the remote management part is shifted to internal. And that means remote management can be dealt by your network administrator. For example, the network administrator can create an express route to your network, or it can introduce a demilitarized zone with stepping stone. He can help you, and then you can really fine-grain your control to the API server. You can also consider to disable the public domain of your Kubernetes cluster, and that means you can only access it by an internal IP address instead of using the publicly well-known address of your cluster. You can just guess it. This is all quite nice. practically making it impossible to remotely manage your cluster. But you do need to manage your cluster. You need to deploy workload on it. You need to do application upgrades. You introduce new stuff, new namespaces, new applications. So whenever you need to do a deployment, then you're probably using it, you're probably doing it by pipelines, which means that you need to have a build agent that is able to communicate with your API server. There are a couple of options for that. For example, you can deploy an agent inside the VNet. It's quite easy, but the agent itself also comes in a containerized version. So you can download a container image for the VSTS agents. It's been published by Microsoft. And if you deploy that inside your AKS, you're in the VNet and you can deploy workload from that build agent to your own AKS server. You can use that for deployment, but not for building purposes. You don't want to build container images inside a cluster. That basically means that you need to have a gateway from your container towards the container engine of your node. That is actually reducing your security. You can also consider to introduce GitOps, which is putting the world a bit upside down, because when an agent is actually pushing your workload towards the cluster, GitOps is doing it the other way around. GitOps is remotely monitoring Git resources, and as soon as sources in that Git repository will change, it will apply those changes in your cluster. So it means instead of pushing things to your cluster, you're pulling things. And that switch from push to pull greatly reduces your firewall complexity. GitOps is, well, it's quite doable. It takes a couple of hours to set up in the first place, but also note that Microsoft is working on this to make it even more intuitive. Note that the GitOps preview extension has been added to the blade in the left of AKS recently. So as soon as this goes out of preview, it's probably just a couple of clicks to get GitOps up and running and get your resources linked to a remote repository. Let's focus on the network. Because in the right of the reference architecture that I've shown in the start, you saw there were external sources over there. And these are the icons for Azure SQL or Azure Cosmos DB. They're marked external over here, but do they have to be external? That's basically the question. They don't have to be. Azure has quite a cool functionality for this, using service endpoints and private links. And using service endpoints and private links, you make your external sources internal. Let's again go to Azure. Inside the resource group over here, I've deployed a Azure SQL instance. This. The same counts for Azure SQL. I need to control who is able to access this server. In the security here in the left, you can see that I've denied public network access. And that implicitly also disallows all the other Azure services to connect to this resource. So basically no one can contact this server, except the virtual network that I've added over here. And this is also the same virtual network that runs AKS. You see that it has an address range of 172.16. And by adding a private endpoint connection, you're going to add a link between Azure SQL and the VNet. This private endpoint has a DNS configuration. You see in the DNS configuration, it will add an extra network interface on the VNet. It gets an internal IP address, and by adding a private DNS server, you can automatically link the FQDN, so the fully qualified domain name of Azure SQL. You link that domain name to the internal IP address. How does that look from inside? Let's do a few commands inside the AKS cluster. Inside the AKS cluster, I've already deployed a pod. And the pod is the tiniest possible thing to run a container image. Which image am I running? I'm running a BusyBox image. And BusyBox is a small Linux container containing a few popular command line utilities of Linux. The container itself isn't doing anything, it just sleeps, but this allows me to execute commands from inside Linux, inside the AKS cluster. Now, what is the command that I want to execute right now? So I'm going to execute in the default namespace on the BusyBox a ping command. And I'm going to ping the Azure SQL instance shown here. Azure SQL isn't actually responding to ping, but you can still see how this Azure SQL instance got resolved. And you see it uses the internal address of the VNet. So using this, let's break it. So using this, you have basically pulled your external sources inside the VNet of AKS. And this is not an Azure SQL only story. You can do this for the most popular Azure resources like Azure Storage or Cosmos DB or KEYVAULT. Even Azure Container Registry is having this feature in preview functionality. Let's continue, because as soon as I'm able to access the Azure SQL instance, I need to be able to connect to it. And that connection string usually contains a secret. Now, how do we get those secrets inside Azure AKS? A pretty straightforward way is to inject those secrets straight from the pipeline, because your pipeline is able to access your KEYVAULT. There's a regular task available in all the Azure DevOps pipelines. It's called Azure KEYVAULT Add 2, and this retrieves all your secret and certificate data as a variable inside your pipeline. As a subsequent step, you can use those variables and apply them in a replace token task. Let's see how that works. Again, we're going to the cluster. I have a deployment over here. A deployment is running one of my containers. It's this container I've specifically created for this talk. And this container needs a connection string. This connection string has to be injected because pure configuration needs to be injected into containers. And the popular way to inject data in containers is using environment variables. If you have injected it, then you can initialize an SQL connection using the value in the environment variables. Now, how do you do that? See over here, inside this container, I have an environment part. And here I say I want an environment variable with the name connection string. And instead of putting a hard-coded value here, because that would basically persist your secret inside your Git repository, which you don't want, I'm going to reference a value from a secret key reference. And the secret key reference is also named connection string. This is not a KEYVAULT secret. This is a regular Kubernetes secret. So the connection string over here is referring to the connection string over here. And we have to fill this secret with the data of the connection string. And over here, you only see a macro syntax. So this is not the real secret. And that is the part that you can inject using the pipeline. If you have the pipeline over here, you can run the Azure KEYVAULT task. It will download all the secrets, also the certificates. You can filter them. I didn't do that, but you can do that. And then using the replace token task, you can replace that contact. So I have a custom token pattern with the macro start tag and the macro end tag. And immediately afterwards, the deployment YAML file is ready to be deployed. And by using these three steps, you can inject secrets just before deployment. The same option is there for certificates, and the good thing for certificates is that the output of the Azure KEYVAULT task and the input for your secret inside Kubernetes is both base64 encoded text. So base64 encoded text comes out the task, and that's the same content that you can inject straight into your certificate and key data. This is one way. You already saw that the parsing of the YAML file was a bit awkward. There's a more clean solution recently introduced. And in fact, that option is also the only way if you're doing it the GitOps way. Because if you're doing it the GitOps way, then you're remotely monitoring that YAML file. And in that YAML file, you don't want to persist and commit and push secrets. You're lucky, the Azure KEYVAULT provider for the secrets is a CSI driver that has been promoted recently to general availability. So it's ready for use in your production environment. And this uses Azure Identities to read secrets and expose them in volumes. You have to enable an add-on while activating AKS. You can also enable the add-on later, by the way. And it works slightly different, but quite interesting. Let's take a look at that. Again, we're going to deploy a BusyBox container. Again, sleeping, not doing anything special, but in the bottom you see an extra addition. I have mounted the volume to mounted drive secret store, and this mounted secret store is a volume here. The name of this volume mount is referred one-on-one in this volume, and this is a CSI with a driver of secret store. It's read only. And it's referring, there's a line missing over here, I guess. Yeah. Well, that was a surprise. It's referring to a secret provider class, which is called Azure KEYVAULT name, user Microsoft identity, Microsoft Service identity. Well, there it is. This is the secret provider class referred over here. This secret provider class actually refers to the Azure resources. So I'm going to Azure. I'm not using pod identity, but a managed identity. And the managed identity that I want to use is this GUID. Well, where does this GUID come from? We got that for free when we enabled the Azure KEYVAULT add-on in AKS. When we enabled the Azure KEYVAULT add-on, we got an extra identity. Inside the Know the Resource group, there's suddenly here a managed identity called Azure KEYVAULT Secret Provider. This is the identity that has read access to my KEYVAULT. This KEYVAULT. And I'm going to expose only one secret, and the secret is called CSI sample. Let's go to that KEYVAULT. Inside the KEYVAULT, I have the secrets. We had the connection string already, and now we are going to look towards the CSI sample, and the value of this secret is, well, secret, of course. But how do we get this in? I've already deployed this, so I can execute a command over here. This is the deployment. And then I'm going to do a list on the mounted volume and see what's inside this pod. And you see there's only one file over here, and the file is called CSI sample. So it's actually a file. Now, what's present in that file, we can show you that using the cat command. And that's going to expose something really secret. So using this, you can access your secrets from a separate container. You can refer to a CSI driver, and the CSI driver will fetch the KEYVAULT stuff for you. And this also means that you don't have to persist your secrets in your Git repository. So very cool. You still have to be beware. Secrets are not secret anymore if you have access to the API server. You saw the resources that I've just deployed. If you do kubectl get secrets, then you'll be able to see the internals of the secrets as well, and they are just base64 encoded. They're also not secret if you have access inside the running container, because you just saw, a secret is just a plain text file, and it contains the secret over there. And the environment variable is also not encoded. So you have to make sure that nobody has access inside your container. The software that you run over there needs to be secure. The first example, where I replaced it just before deployment, will also make you responsible for destruction of the replaced file. You don't want to persist that, because then you're persisting content, including your secrets. Let's go a little bit further into those Azure identities, because AKS is even more integrated with Azure identities. And especially in the management part, you will notice that. If you create your AKS cluster, you have the possibility to enable managed identity. And that managed identity is used to manage your cluster resources. So again, that node or resource group comes into the picture. How does it work? At the time of AKS creation, I had a managed identity which I linked to this AKS cluster. It's just an additional command line. Now, what happened under the hood? The node or resource group that got created next towards AKS has a role assignment to the same user managed identity. So this way you can control who has access to your node or resources, and AKS will use this identity only. The same trick is there for hooking up your AKS environment to a container registry. It will use a slightly different identity, but it's still managed. And it will just grant the ACR pool role to the managed identity. You can also link the roles inside your cluster to the Azure roles that you have. So if you enable AAD and enable Azure RBAC, then you can link the admin group object IDs to your AAD group IDs. You can even disable local accounts, and this means that you have entirely promoted your management user infrastructure to Azure, which is cool for management. But on the other hand, you also want to run your workload using Azure identities. And over here, the story is slightly different. I'm not that optimistic on that as per today. AAD pod identity has been there already around a year or so. It's actually still in preview phase, and that's where the caveat is. It's a long time in preview, and I'm convinced it won't make it to generally available. And V2, already the replacement of V1, won't make it either. The successor of AAD pod identity has already been introduced, and that uses Azure Workload Identity, and modern technology where you can impersonate using OpenID Connect. So the OIDC issuer actually stands for OpenID Connect, which is internally based on top of OAuth 2. And using Azure Workload Identity, you can even link Kubernetes clusters that are running outside Azure to your Azure identities, which is quite cool. I was really motivated to show it to you today, but it requires an AKS preview extension that I couldn't get hold of. It's a little bit too new for this tech talk. So all I can promise you is to stay tuned on the link that I've mentioned over here. And I will promise you that I will do the same. If this is all done, then you can achieve the situation in the bottom where you have a default Azure credential, a default connection string that uses integrated authentication, and using the Azure credential token, you'll have impersonated yourself to an Azure identity. Now, the last topic that I want to cover today is around secure containers. We got the secret part and the identity part, but what if the software that's running on your cluster is vulnerable or malware? You don't want that. And if you want to achieve that, there's only one golden rule. You have to know what you deploy. You're probably building your own software, so you're building your own container images. Please base them on well-known official images like Microsoft provides for .NET Core. So if you use a base image like this, then you're probably good to go. Microsoft will make sure that they have done their homework, and you get a pretty okay base container. The container in the left bottom is mentioning Apache's Cassandra. I would trust that as well. It's been marked as an official image on the Docker Hub. It's been downloaded 100 million times, so it's quite used a lot. I would trust that. In contrary to the container that is there in the right bottom. This is actually one of my own. I didn't remember that I had it. It's doing some service discovery for dev work. It's also created 4 years ago. Who knows what's inside it? At least I don't remember it. But still, you can see this image has been pulled 9 days ago. I wouldn't want to run this container image on my cluster. Who knows what it will do, what it will scan, what it will send, etc. Basically, I trust the left two parts. I don't trust the right part. You have to know what you deploy. If you're still unsure, or if you want to have proof that your image is safe, then there are tools for that. For example, Qualys, but they're actually more third-party tools that you can inject straight in your pipeline. They will scan your image, and if you do it just after building, before pushing, then you're right in time to prevent pushing of malfunctioning container images. So this is about build time, quite okay, but vulnerabilities can be recognized later as well. Suppose I created a container last September and in last December the log4j vulnerability came out, then still my container is out. It's out in the registries, people can download it, I have probably deployed it. You also need to scan your containers after they are pushed. There are two options for that. In the right, there is the screenshot of the Docker Hub. You see that there is a link here that enables vulnerability scanning. You also have to enable your credit card, but afterwards it works. Microsoft has the same functionality inside Microsoft Azure using their Microsoft Defender for Cloud. And this is actively scanning the images that are present inside Azure Container Registry. As soon as there is a vulnerability found, it will raise an alert and you can hook up your action groups, send an email, or get a push notification, those kind of things. So we've come to the end. Let's go to the slides that I've shown in the start. This was the basic AKS reference architecture. And what did we cover? We shown how our pipelines can work with AKS and how they can do secure Docker pushes, how they can connect to the Kubernetes cluster, how Kubernetes is able to pull images using managed identity. We've protected the API server, and we've protected the API server using Azure role-based access control. And we've also shown how to get your Azure KEYVAULT secrets inside the cluster. At last, we have seen that we can actually pull the external data sources inside our VNET. There are also a few question marks which we didn't cover today. They're all about the Kubernetes internals. Kubernetes has its own security stuff, its roles, its privileges, role bindings, etc. And there are also internal network policies. Like the network security group of the VNet is exposing the outside world or protecting your cluster to the outside world, but Kubernetes has functionality to prevent that front-end pods can directly talk to Elasticsearch, for example. So you can limit the way which namespace can communicate with another namespace. Let's keep that for later. I also didn't talk about the way you're going to expose your front-end application to the outside world. So over there, you have the possibilities for Azure Application Gateway and then the Web Application Firewall, the WAF feature. Let's keep that for later. Last but not least, I want to give you the message that you should not forget all the other security stuff as well. You only need one weakest link and then you're still lost. If you don't do pen testing and people get access inside your container, they will have access to your secrets. If you don't protect your workspace, then people will still have access to your AKS cluster. If you put secrets inside log files, if you don't do the OWASP.10 while developing, etc., you still have to do all the other stuff on top of protecting your AKS infrastructure. Here are a few great articles published by Microsoft on their security baseline and security concepts. Keep an eye on the article about Azure Workload Identity and OpenID Connect. And you can read all about the private DNS endpoints. I guess that was all I had to say to you tonight. So thank you very much for your attention.
Thanks a lot. Really great session. Very interesting. A lot of great security features that you've covered in this. We have some questions for you in the chat. Kaushik
Okay.
was very, very active in the chat. He has 3 questions for you. So let's start with the first one. He asked, is it possible now to manage the API server host certificates and client certificates, such that the on-premise nodes can be integrated with it, more in the direction of Azure Arc, for instance?
Arc enabled AKS. That's quite an interesting question, but I don't have the answer for you. I'm sorry.
Okay. Yeah, different product. Yeah. I can imagine that. So, yeah, Kaushik, you need to Google that one, I'm afraid. Okay, but he has another one. Let's take the next one. Okay, are there any use cases where there is a need to SSH into the nodes?
Yeah, good question. I think if you're a DevOps agent, and especially while you're troubleshooting or doing, when you have complex workloads, then you have also different node groups, and then you have also different network challenges. So, in that case, you basically want to go into the nodes and get access to, like, see what you can do if you're running inside a node. I wasn't doing that. I was running in a container inside the cluster, which is slightly different. It gives you the same approach inside the same network. So SSH into the node is like only in case of real troubleshooting, I guess. I wouldn't do this on a daily basis, to be honest.
No. I think I agree on that. I think I read somewhere that this is not a best practice on your production environment. No. So, yeah.
The nodes are probably untouched. Like they're managed by AKS as well. So like the security updates on the VMSS, they are all automatically updated. And if you want to update your Kubernetes nodes as well, that also goes through Azure. So if you increase Kubernetes by version, so you go from 123 to 124, then that's a managed command by AKS. The whole idea of having AKS is that you don't need to manage Kubernetes itself. Azure will do that for you.
Yeah, agree. Yeah. Okay, one last one. He agrees that the CSI driver is helpful, but if you use this, are the environment variables still valid on the pod? And does the application needs a sidecar to read secrets from the volume mount?
Yeah, and the latter. I guess you need to inject that as like a separate configuration add-on if you're doing .NET Core development. There's no such thing as that you would have with environment variables. If you're doing a .NET Core development, .NET Core configuration, then you can inject all your environment variables straight into your application settings. There's, well, I guess not natively. There's not an add-on that does the same. So you still need to do something for that, or get a NuGet package that does the same.
Okay. Thanks. And thanks, Kaushik, for your interesting questions.
Yeah.
Thanks a lot. Yeah. So then we're now at the end of it.
Thank you very much.
You.
I hope it inspired you a bit.
Yeah, it really did. I made some notes, and I'm going to look into a couple of topics that you've covered later on. Yes. Really
All
interesting.
right.
Learned a lot from you. Thanks a lot.
Thank you. Have a nice evening.
Have a nice evening. So now it is time for our second speaker, Frank. Hi, Frank.
Hi, thanks for having me,
How are
Sjoukje.
you? Thank
I'm
you for
well, thank
being
you.
here. Yes. Can you introduce yourself a bit before we start?
Yes, of course. My name is Frank van der Peet. I'm a senior software engineer at Capgemini in the Netherlands. I started out with mobile development for iOS mainly, made a switch a few years back to web development as well, mostly .NET backend development, but also a few front ends. So at this time, I'm currently learning myself how to use Angular, which is a new framework for me. So I'm also using some front-end frameworks as well. And tonight I'm going to talk a little bit about Terraform, which is mostly a cloud-native tool, actually.
Yeah, and Terraform in Azure in this case.
Yeah, Azure as well.
Yeah. Yeah, nice. So pay attention to Frank his session because at the end of this, we're going to ask you a question and you can get a chance of winning this awesome hoodie. So pay attention. Frank, the floor is yours. Good luck.
Thank you. My session tonight will be about Terraform and mainly how to deploy resources using Terraform to Azure. I already had a nice introduction by Sjoukje, so I'm going to skip this slide for now and get started with what is Terraform. Terraform is an open source piece of technology. It was created and is still maintained by a corporation called HashiCorp. It is a very modular approach. So if you download Terraform, you get a single executable, which is just the core application. And on top of that, we're going to stack providers. In this case, tonight, we're going to use Azure, the Azure provider. So you have to download that provider as well. And it can be used for all other sorts of deployments as well, not just for Azure. As already been discussed, Terraform is technology for infrastructure as code and basically declarative infrastructure as code. So let's elaborate a bit on that as well. Infrastructure as code. There's basically two flavors. The first one is imperative and the second one is declarative. But just to roll back a little bit, why would you use infrastructure as code and what is it? Well, if you don't use it, you probably, for instance, if you want to deploy resources to Azure, like tonight, you're going to use a browser and go to Azure portal, or maybe use the CLI and use the Azure CLI, maybe the PowerShell SDK, and you will be rolling out a single resource. Then once it's deployed, you're going to make some changes to it. Maybe a few weeks later, you're going to do a few adjustments again. And every time you want to do a change, it is a very manual approach. And every resource you have to manually touch. So with infrastructure as code, as the name suggests, we're going to use code to define what our infrastructure is all about. So again, imperative and declarative. Imperative is basically that you give a set of commands. So like you used to do before, you go through a set of commands, but they are automated. So for instance, if you have a PowerShell script where first there are some dependencies that are being pulled, then there's some authentication, then a resource is deployed, another resource, etc. That will be a form of imperative infrastructure as code. And then when later on you want to make some changes, you're going to make a new script or adjustment to a script and roll that out as well. Declarative, on the other hand, as Terraform is, here we're going to declare what we want our infrastructure to look like. So we're going to say, I want this resource with this configuration, and then that resource as well, and then inside that, I want another resource, and just ask Terraform nicely, deploy it for me. And Terraform will do its best to deploy it, and then later on, if there's are some changes, we're just going to make changes to this same configuration file, make the changes, and ask Terraform again to apply the changes, and it will figure out what has been changed compared to the last time it was deployed. One of the main benefits of infrastructure as code is that because it is code, we can treat it just like we do our usual application code. So we can check it into Git, in source control, Git. We can work on it together, can elaborate with team members. We can track our changes, see what happened. And because of this, we also have kind of a single source of truth. So for instance, if we make a deployment and then a bit later, someone of our team makes some manual adjustments, and then we apply our Terraform changes again, those adjustments will be rolled back because the configuration we have declared says that the infrastructure should be as it was before. Only when we make change to the Terraform configuration, then those changes will stick. And because of all this, it is very easy to maintain. It is easy to work together. It's a lot faster, and it's also repeatable. So if you have a few different environments that you want to roll out to, you can do that easily and make only changes in one single place. And also, if you want to take everything down again and then build everything up, then it should be exactly the same as it was before. So it's very repeatable. And because all of this is also automated, it can also be automated. So tonight we're going to do it manually. We're going to use run the commands ourselves, but eventually you can also do this from a pipeline, for instance, in Azure DevOps. So it can be part of your continuous delivery cycle. So enough talk. Let's get right to it and start terraforming. What we have is Visual Studio Code here, and I'm also going to show you a few things on the Terraform website. Again, we have the Terraform application, which is just the core application, and I have it installed already. So it's just on the website, download it and install it, and I've added the location to my pod environment variable, so I can run it from everywhere. And let's see what we can do with Terraform. So we're going to just run Terraform help and see what kind of commands it has in store for us. As you see, there's quite a few commands, and a few of them also have some subcommands and additional flags. We're not going to go through them all tonight, but I want to touch on the main commands first. So these ones we're all going to do tonight. And to explain them a little bit is we're going to start with init. This will set up Terraform on my workstation for this deployment. We're only going to do this once. Afterwards, we're going to make changes, and we only need to apply those changes. And it will also download the providers that we specify and set up a few files. Then we have the validate command. This will check our configuration or our code, whether it's valid, see if the syntax is correct, whether we supplied all the necessary arguments everywhere, things like that. Then we have the planning phase, which is kind of a dry run of the deployment. So it will validate just like the validate command does, and then it will check whether we can deploy it to Azure, and it will check the current state that we have and our code and see what needs to be changed. So which resource need to be added, which need to be destroyed if necessary, and what changes for existing resources are there planning to be applied. Then afterwards, we have apply, which is the combination of validate, plan, and then apply. And this is where the actual work gets done. So when we do apply, we first get a planning stage. After the planning stage, we always get a nice report of everything that needs to be done. And then if we accept that report, it will actually deploy our changes to Azure. And finally, something I don't do very often, but is destroy. This means it will take down everything our Terraform configuration has deployed so far. So these are the commands we can do. We are going to do. How do we get started? Well, we have an empty folder here. All we need at first is a single file, and let's for tonight call it build. The actual name of the file doesn't matter that much. What does matter is the file extension. It needs to be .tf. That means that Terraform knows that this is a Terraform file and knows how to treat it. But then we have an empty code editor. So how are we going to start? For this, I want to switch over to the Terraform website. This is where you get to. You can download the tool here. But for now, we're going to go to the registry. Because as I said, we're going to need a provider first. And that is, those are stored in the Terraform registry. So in the registry, we're going to go to Browse Providers. And here we'll see all the providers that are currently available to us from Terraform. If I scroll down to the bottom for a bit, you can see that there currently are 1,840 providers, and the number is growing every week. And you see that most common cloud platforms are available like Azure, but also AWS or Google Cloud. Tonight we're going to focus on Azure, but do note that other cloud platforms are also available, and you can also mix multiple cloud providers in one infrastructure configuration. Other options are down here, for instance, Azure Active Directory, if we want to register certain applications using Terraform as well, or Active Directory on-premise as well. It's possible. Kubernetes we can do, but there are also simpler, smaller providers. For instance, we have a random, which we can use to generate random passwords, GUIDs, strings, numbers, etc., which can come quite handy sometimes. But let's focus on Azure tonight. So here we go to the Azure Resource Manager provider, and we're going to jump straight into the documentation because there's a lot of documentation and we're going to make use of that. So on every page, you'll see some basic information and at some point some example usage, which is quite handy. And then we're going to see all the different arguments that we can use as well. For now, one important thing with the provider is also that we have a section called authenticating to Azure, which is very important because, of course, Terraform needs to be authenticated to deploy resources and needs to know in which subscription it needs to happen and also needs to have the necessary permissions to do so. There are a few ways we can do it. We can use the Azure CLI. This is what we'll do tonight because it's very easy. I've already run the command az login and authenticated with Azure, so I can just run deployments for my subscription as I want. Other options are managed service identity or service principal. And how you exactly want to configure that, those are also explained here or on their exact pages. For now, we're going to keep it simple and we're going to look at the example usage because this is a nice scaffolding to get started. So we'll start with the top of this and we're just going to paste it in. And what we'll see here is we have two different blocks of code. We start with the Terraform block, which is something you always have at least once or should have once in your code. This is a block just to let Terraform know, like, this is a Terraform configuration that we're working on. Here we can have all the general Terraform settings for this deployment or for this infrastructure. What the most important and the only one we're going to use tonight is the required providers. So here we got in this block, we'll say to Terraform, these providers are required. And the only one we have is Azure Resource Manager, and the source is Azure RM, as we saw in the documentation before, and version is exactly 2.91.0. We can also specify here that we want at least a certain version or maximum version, but most of the time you just want the latest version and you want exactly that version. Then the next block is a provider, and here we have the name Azure RM, which corresponds with Azure RM down here. And here we only have an empty features block, and that is because if we go back to the documentation and look at those arguments, we're going to see feature is required, but it does not need to be filled out anyway. And all the others are just optional, but they can do certain settings for Azure specifically, or supply certain, like for instance, the subscription ID if you have multiple subscriptions in your account, and lots of other things. But we're going to keep it simple for now and just use the basic setup. Now, this is also the moment where we can give our first command. And if you recall correctly, the first one is Terraform init. And this will, again, I need to save the file first, because otherwise it's very fast and it doesn't do anything. So now Terraform init, it will say it will initialize the provider plugins, and it will start finding, installing, downloading everything, the Azure Resource Manager version we specified. And while it's happening, you already see that something is being downloaded. So a new folder is created, .terraform, with a lot of subfolders, and inside we'll see the Terraform provider has been downloaded, which is now executable. This will contain all the necessary resources we're going to deploy tonight. So next up, our first resource. So the most logical thing to first deploy is a resource group. So how do we do that? Well, we already had a Terraform block, a provider block. So we'll start with a resource block. And you'll see that Visual Studio Code is already helping me here along. So it's filled out a resource and then 2 strings. In the first one, we have a long list of choices we can make. But we'll start typing Azure Resource Manager resource group. And then we have a name that we can supply ourselves. How this happened that Visual Studio Code is helping me is because I have the extension installed for Terraform. So here we have the Terraform extension, which will help with syntax lighting and auto-completion for Terraform. So this is what is helping me at this moment. And as you see, there's a specific kind of markup or a syntax that we're using. So we have the Terraform block, the provider block, and now the resource block. And the resource block first has a type of resource. So this is the type of resource we're going to create, which is a resource group in Azure. And then we have a name that we provide ourselves. And this name needs to be unique, but it only needs to be unique across resource type. And how that is because the actual name Terraform gives this resource internally is Azure RM _resource _group dot build. And this way we can, it keeps track of what has happened since the last deployment. But I'll get into that a little bit later. So what can we do inside this resource group? Well, again, we can go to documentation because Terraform is pretty well documented and it's also very necessary because we're not going to remember all these things. So I know we have the Azure Resource Manager resource group. And again, it starts out with a few notes and general information. Then we have a nice sample usage. And then we see the arguments that we can specify. The resource group is very simple. So we only have 3 arguments. We have a location where we want to deploy the resource group. We have the name of the group. And then optionally, we have some tags that we can apply to them, which is common for most Azure resources. So location and name, those are required, and those are just simple strings. So if we start typing, it will help us along again. So let's get the resource group name. Tonight we're going to call it resource group build tag 01, for instance. And we're going to need a location, and that will be West Europe. We're going to deploy everything in West Europe today. So saving again, and this is the moment we can fire our second command we talked about. So we're going to go to Terraform and type in validate. So again, all this does is just check whether the code that we have currently is valid or not. For instance, if I type some weird characters here, the name is messed up, then it will not validate, it will give an error. If I leave out the required argument, it will also not validate. But as you see, success, the configuration is valid, which is also always nice to see. And right after that, we can start our second command, which was Terraform plan. And if you recall correctly, this will see what needs to be deployed and make a report of it, but will not actually deploy anything. And also something that we could do with Terraform plan, because both validate and plan we're not going to do anymore after this, because apply will do all those things and more. But what you can do with plan is also export that plan. And then when you do the apply, you can take that report or that plan actually as the input for the apply. So it will not, during the apply, it will not check your code again, but it will just use a file you specify. Be wary with that, of course, because if you create a plan and then weeks later you want to apply the plan and a lot of things have changed in the meantime, that will give, of course, a few errors. So in most of the cases, it is best to just use Terraform apply. And also, it will not apply it immediately. It will first prompt you with all the changes that are going to be made. And afterwards, if you accept it, only then the actual deployment will take place. Well, while this is running, we're going to continue with our next resource. Oh, I already see that it has completed, so let's take a look at it. So it says Terraform used to select provider generate following execution plan, and it uses a green plus mark to specify which resources will be created. And as we'll see, we have a resource group name built internally, and it will have an ID, which will be known after the deployment, because it's generated by Azure. We have a location, Western Europe, and we have a name as we gave it. And the conclusion of the plan is we're going to add one resource, change nothing, and destroy nothing as well. So that seems like a good plan. So before we apply it, let's continue with another resource. Just to keep things simple, we're going to deploy a virtual network. They're very fast, and they don't have too many arguments. So again, let's go to documentation and see what we can do with a virtual network. So here became more known already. A few notes, general information, an example usage, and then we get to the arguments. Again, we'll need a name is required. We need the resource group to deploy it in, of course. There's an address space that's required, and it's very important what it says here. You can supply more than one address space, which means that it's not just a string, but it's an array of strings. Also, location is again required, and then there's a bunch of optional arguments that we can supply. For now, let's just start with the required parameters. So, if I recall correctly, we have a name. So we call it VNET build tech 01. Then we need a resource group name. So let's wait for the completion. The name of the resource group it wants. So we're going to deploy it in this resource group we are also going to create. So just use that name. Then the location, well, as I said, tonight everything will be in Western Europe. And then finally, we had an address space. And like I said, that is actually an array of strings. And just give a simple address space. It's not very important for the Terraform part of it. So this is our second resource, and it will be deployed inside the resource group we also create. And already I see a few things that can be better, because this feels kind of odd that we have a literal string that references something else. And also, we're already a bit repeating ourselves, because we have this part of build tag, which is sort of a name convention, a name prefix, and also the location, because like I said, everything will be West Europe. So are we going to repeat ourselves for everything with that? No, there are things that we can improve upon here. So let's start with that resource group name, because it would be a lot better or nicer if we can just reference the other resource here. And that's possible. So instead of giving it a string, we're just going to reference the other resource. So it's already giving me some code completion. The resource manager resource group build. Yeah, that's the one we want. And then inside there, we have three types, which have the type string, which is the ID, the location, or the name. And we wanted to have the name. For the location, let's just do the same. Let's just make the resource group leading and just reference it. So the resource group and take the location. So that's better. Now, also, we saw something with the naming convention, and we can make some constants for this. And we do that using locals. So we define another block called locals. And inside, we'll make one, let's call it name prefix. And the name prefix, we're going to give a value of build tag. And then inside those naming conventions, or those name arguments, we're going to use string interpolation and reference that local. Now there is a bit of a catch here because it feels a bit off. This is called locals, plural. This is called local, singular. But this is the way it works. So we have local name prefix, references to that, and we're going to use this here as well. Yes, that looks good. So let's see. I think we're ready to deploy something. So we're going to use another command. Terraform apply is the next one. And this will take a little while, also because my workstation is a bit slow because of the screen sharing momentarily. So in the meantime, let's talk about something else while this works. Now, we've had a few blocks in this configuration file. And you see there's a logical order at this moment, because we start with Terraform main configuration. Well, this one I actually intended to have a bit lower here. Then we have because then we have the provider. Then we have some local variables or some constants, basically. Then we have the first resource, and then we have another resource that will be deployed there. But actually, the order in which we declare this doesn't matter at all. I can take this block of code, put it all the way at the top, switch it around however I like, and it will still work exactly the same. It does not treat the order of the configuration in any way. Even better, I can, like I said, the file name doesn't matter as long as the file extension is .tf. I can also split this up in multiple files. I can split the locals up in a separate file, provider and the Terraform configuration in one other. I can even split up like every resource in the separate files. It will still work exactly the same. This is very nice, but it has also a bit of a downside, because how does it know that the resource group needs to be created before we have the virtual network? If we kept this reference here just like literal strings, like we had in the past, it wouldn't know that it needs to be this one, then a virtual network. But because we reference the resource group in this resource, it knows that the resource group needs to be created before we can deploy this resource. So in this case, it will work exactly as we intended to. If we don't use this and just return this to the strings that like we had before, we can still specify a certain order of creation. And that is by declaring depends on. So in a resource, if we say depends on, we can reference which resource it depends on. So this is not necessary at this moment, but if we specify this, the resource group needs to be created before we can create the virtual network. So I'm going to return it, and in the meantime, our plan has gone through. So now we're going to add 2 resources and change nothing and destroy nothing. And if I take a quick look at it, it all looks quite all right. So yes, we're going to deploy it. And in the meantime, let's switch over to Azure for just a moment, because I want to show you that currently we have 2 resource groups here, which are these 2, and we expect to see a third one in just a bit. If you've been paying attention, you see that on the right side, a few files have been added. Well, the Terraform log and state log are intermediary files for Terraform. And actually, all these files are not supposed to be touched. You should just stay away from them. But the Terraform.tf state file, I do want to show you at this moment. Because how does this work with the creation and the comparison and apply and then make changes and then apply again, is because Terraform keeps track of a certain state. So all the resources we deploy, all the changes that we apply, will be saved inside the Terraform state. And then when we make additional changes, it will compare the state from the last time with the current code. And if you make changes in Azure, it will also update the state before it will do the actual apply. So if we look at the state, we see it's just a simple JSON file. We have some general settings at the top, and then we start with an array of resources. And in these resources, we see we have a resource group that we name build, and inside we see the configuration that we provided, and also, which is very important, is the ID, because this is the ID as it is known to Azure. So because of this, Terraform knows that the resource group we call build is actually this ID inside of Azure. And if we scroll down, we also see our virtual network, which I see we have not given a name, which is my fault. And we also see the settings, and again, an identifier in Azure. Well, the deployment has been completed, so let's switch over for a moment and see if it's good. Yes, we see the resource group here, and inside we should see that it has a virtual network with a certain name, and it is deployed in Western Europe. And a virtual network is also deployed in Western Europe. So that all looks good. But what, for instance, if you already have a few resources deployed? So you have resources in Azure, and you want to use Terraform to keep track of them and to update them in the future. So we're going to create, inside this resource group, we're going to create another virtual network. So not using infrastructure as code, but just the manual approach. And we're going to create it. It's already wise enough that it chooses our resource group. It's currently loading the region and Western Europe as well. And we're going to call this VNET build tag 2. Just keep it simple. I'm going to create it right away. Do note that the address space is slightly different than the one we had before. So we're going to create it. This will run for a little bit. And in the meantime, we have to declare this in Terraform. So I'm just going to take this resource block, copy it, call it build2. Again, give the name with 2 as well, and the address space was a bit different. Let's see if it has been successfully created. Yes, it has. All right, that's good. Now, the problem is that we have the resource now in Azure, and we have the resource in Terraform, but they don't know about each other yet. So if I apply this code at this moment, it will simply just create another virtual network, and it will fail because it will have a naming conflict because this name is already taken. So we have to tell Terraform that this resource is already available. So if we go to the documentation back again, we had a few arguments here that we could specify that were optional, and then some more details as well, some attributes that are being published, so like the ID is being known as well. And then at the bottom, for all the resources, this is true, you'll see an import. And this way we can import an existing resources into Terraform. And we'll also always use Terraform, of course, then the import command, and then 2 arguments. First is the local Terraform name. So again, it's the type of resource and then the name we've given it. And then it's a very long string of identifier for the resource. But it is long, but it's not that difficult because it starts basically always with subscription. Then we have GUID, which is our subscription ID. Then we get to resource groups, then the name of a resource group that we want to deploy it in, then a part with providers. And then in this case, it's Microsoft.network. For instance, if we had a storage account, it will be Microsoft.storage. Then the type, which is virtual networks, and then the name of the network. So it's quite easy to get a hold on these variables, but it's even simpler. So if we go to a virtual network that we've created and down to the properties, here we just see the resource ID, which is exactly the type of string that we need. So let's import this resource. So again, Terraform import, then the local name, which is the resource type dot build 2, and then at the end we need the identifier in Azure. So this is not correct. Copied. All right. Yeah, that looks more like it. And then we're gonna make it work, and it will import the current resource from Azure into our Terraform state file. Now, this state file, currently we have this locally, but if you work together with other team members on the Terraform configuration and you want to deploy it from multiple locations, so you want to deploy it from your development machine, but also from a pipeline, for instance, then it would not work, of course, because then you need to pass around that state file. That's not something you want to do. Instead, you can use a backend, which basically is a remote state file. So we can store this state file in, for instance, an Azure storage account, and then we can reference where that state file is located, and also, of course, some credentials are necessary in this case. And then Terraform knows that we can pick up the state file there and just update there as well. For tonight, we're just going to work with the local version. Now, something else as well, I don't like it that much that this is called name. It should have been build 1, for instance. And this is import was successful, so that's good to know. What we also want to do is change this name for now. This is also a problem because, as I mentioned, these two together are the identifier for the resource in Terraform. So if I would apply this change now, it would be unable to find a previous resource called Azure Virtual Network name, because that was named before. So it would destroy that resource that we created. And then afterwards, it will create this one because it seems like it's a new resource. So we need to update our state here as well. And of course, you can do it right away in the JSON file, but you shouldn't really touch that state file because it can be corrupt quite simply, and it's not something you would want. So it's very easy to rename this. All we need to do is update the state file. In this case, that means Terraform state, move, and then the name, like it was before, like it is known to the state at this moment, which was name, I recall, and then the name that it is known as now, which is build 1. So this should update our state file that the name has changed. And if I apply this infrastructure afterwards, it should all work fine. Let's wait around for this one moment, because then I can show you in the state file that things have changed. Yeah, successfully moved, great. So going to the state file, we should now see that the virtual network is now build 1, and the other virtual network is now build 2 and is supplied here with correct identifier. So that's great. Now, for our final part of the session, I would like to show you another Terraform configuration I've prepared and show you a few things here. So what we have is, well, first, just let's get it started because it takes a while. So all we need to do is first Terraform init to initialize the plugins and providers. And in the meantime, we can walk to the resources, and it looks very similar to what we had before. So we have 2 virtual networks inside a resource group. But also, if you look closely, we have a folder with those resources and a few other files. And then we have in the parent directory, we have a main configuration. So let's get this started. Terraform apply. And I'm going to auto approve as well. So what this is we have, this is our configuration actually, and this is a module. So a module is a Terraform configuration that we can reuse. So if we look here in the configuration, we see the Terraform block and the provider block again, and then we have 3 modules: dev, test, and production. And Inside every module, we see a source, which is just a reference to where we can find the configuration. So in this folder, and then we have a variable called naming prefix. First, before it was a local, now it's a variable. So you see that is different for the different modules. So back to the module itself, resources look pretty similar to what we had, but we also have locals in a separate file, which works perfectly, which just have a text component that we then use on all the resources, as you see here. We have a variables component, which has the naming prefix, but also the resource location. And they all have a default value. So if we don't supply it like we do with the location, it will just use the default value. And also we have an output. We have output variables. And in this case, we're not going to do anything with it, but we publish the ID of the resource group as an output variable, which means that if I go to the top deployment, actually, this module dev is an output, which is the ID of the resource group. And I could define a resource down below and use that variable, so the identifier of the resource group, in this declaration. But I'm not going to do that. We're just going to wait till this has finished. And then we should have 9 resources in Azure, because we have 3 different resource groups, and all of them have 2, let's see, where were we? 2 virtual networks inside them. And they have been deployed. So back to Azure, to our home, to our resource groups. And already we see a few things down here. Sometimes takes a little bit of time before it's, yes, there we are. So we see the dev, the test, and production, and all of them have exactly what we expected them. They should have 2 virtual networks, should be in Western Europe, and also has a tag demo modules. So I'm going to leave it at that. I think we have time for a few more questions. I hope you enjoyed this session, and that made you excited to use Terraform maybe on the next project. Thanks.
Definitely made me excited about it. Good session.
Good to hear.
Good guidance on how to use Terraform and all the different aspects of it. We have a couple of questions, so let's start with the first one. So when should you use Terraform, and when should you use Pulumi? And
to be honest, I've never heard of Pulumi, but yeah, of course, there are a lot of different tools out there. Terraform is one of them. There are other declarative infrastructure as code tools as well. I don't know enough about all of those to really give a pro-cons comparison of them. But I can say, for instance, if I compare it to Azure's resource manager templates or blueprints or stuff like that, that one of the benefits, of course, of Terraform or one of the third-party tools is that it's not just for Azure. Because I use it in Azure today, and I've used it in the past, but you can also use it for AWS, for Google Cloud as well. And you can also mix those. So if for some reason you would have an infrastructure which is partly on Azure, partly on AWS, you can import or require both providers, and then mix those resources. So have an app service in Azure and maybe some database in AWS, for instance. So it's not that bound to a certain provider, and it's very, also the modular approach I think is very nice, because there are a lot of other things for Kubernetes and Active Directory and stuff like that. That makes it very powerful. So I hope that's enough of an answer for you.
Yeah. So is that what you recommend in multi-cloud environments? Use Terraform, but if you have a single cloud provider, like for instance just Azure, would you then also prefer Terraform for it?
Yeah, actually, I like Terraform a lot, because it's very easy. It is very quick to deploy. You get decent feedback. Documentation is very good. So there's no real reason not to use it for other things as well. If I had a big project last year, which we used Terraform extensively, And the infrastructure I showed tonight is, of course, very simple. But using those modules, like at the end, is something we used for the different environments. We had a bunch of resources for API management, so all the different APIs, the backends, the policies, all those things were also in Terraform. We even had our application or API registries in Azure Active Directory provided by Terraform. So there's a lot you can do, and yeah, so there's no real reason not to use it, but let's keep it at that.
And did you also use it in CI/CD pipelines?
Yeah,
Because
as
that's
well.
another question. Let's put that one on the from Peter. How would you advise to use that from your automated CI/CD then?
Yeah, that's a very good question, and I wish I had more time to also show that tonight, but maybe another time. No, it's very easy because as I've showed you already, it was just it's code, so it's checked into source control, so you can access that from your pipeline, of course. And furthermore, it's just a single application or executable, and we use command line commands. So it's very easy to automate that in a CI/CD pipeline. But even better is we used Azure DevOps on that specific project. And there's also, what's it called, a third-party plugin from the marketplace from Azure DevOps, which takes care of most of the work. So you have a few tasks. One is install, then a command. So then you can initialize your Terraform configuration. And again, we use the external state, of course. So we had our state saved in storage accounts. And then you can apply it. So we checked and validated our configuration in the build pipeline, and then on the deployment with our different stages, which each deploy to a different environment.
Okay, nice. Okay, let's take the next one because we have a lot of questions still going. Okay, let's take this one. Does Terraform also validate, I think, scripts in subfolders?
Yeah, so if you use a subfolder, then you need to use it as a module, like I showed at the end. So what I said, if you take the first approach we had, just a simple configuration, everything can be split up in multiple files, but it cannot be split up inside a subfolder. If you use a subfolder, it's an intention that you use it as a module. But those modules, if you use it in your configuration, then it will be validated as well using the validation step or the plan step. So yeah, that works.
Yeah. Is there any way to find which resources are created by Terraform and which resources are created manually?
Now, on the Azure side, there isn't, because Azure is aware, it doesn't know if it was created using Terraform or something else or just manually. If you go to inspect your state, of course, then you can see which are created. If you really are doing some sort of mix and matching and need to be able to know which are created, I would just advise to use something like tags. Just declare a tag at the top of everything, like I did with the module or the demo module tag, and just add it to every resource that you create using Terraform. Then if you see that tag as a resource, then you know it's from Terraform.
Yeah, of course. Yeah. Okay. Next one. How can we protect any resource from destroying it accidentally?
Yeah, that's a very good question, because of course with great power comes great responsibility. And indeed, funny story, I have destroyed more than I wanted to at some point on that project, which was actually the case because we started with the development environment, and at some point in that CD pipeline, we started also to deploy to test environments for the first time again. And I had misconfigured the deployment or the pipeline, and it referenced the development state file. So it needs to deploy to test, but it checked the state file for dev. So when Terraform started to run, it checked the state and it saw all the development resources and compared it to the code that we had and said, well, nothing in this state is supposed to be there. So everything from development we're going to destroy, and we're going to build tests. Well, so everything was gone. Of course, that was the dev environment, so it wasn't that bad. But it was an important lesson and something that we started to think about. So either you can not automate it completely so that you also always have to approve before you do the actual deployment, because that's what we did tonight, except for the last time I said an auto approve, like I know that's all right, just do what you need to do. But there's also, just like we used the depends on argument, there's a don't destroy argument. And that is what we at some point put on all the databases, the storage accounts, everything that has some stateful information there. And what this means is that whenever you deploy or apply Terraform, and it hits that point that it needs to destroy that, it will just fail. It will just get out with an error and say, we cannot destroy this resource. And it will try to do most of the other things, of course, but will not destroy this resource. And then, of course, you see in the log files that it has failed, and then you can see why that is, and then you can make adjustments that it will not happen.
Yeah, okay, very good add-on then. Okay, next one. Can you use for loops or if statements in your
Yeah, I needed to have a
Terraform
session for an
files?
hour, I think, because these are all things that I wanted desperately to talk about, but just didn't have the time. So I had to kill those darlings. But yes, at the end I showed you the modules, but indeed you can do some basic for loops and if statements. So you can say, I want 3 VNETs like we did today, or storage accounts or whatever, and then use the increment as in the naming convention, for instance. That is indeed possible. It's very simple, but you can do that to create multiple instances of a resource with the same configuration. And also to add upon that, there are also a few expressions you can use. So you cannot write them yourself, unfortunately, because there are some points that you really want to do that. But for instance, if you have some naming convention and need to convert a string to uppercase, you can do that with a to upper expression, lowercase as well. And there are some find and replace things as well for strings. Basic stuff, but there are some possibilities, and they're all documented very well.
Okay, so we need to schedule a part 2 then.
Yeah, that would be nice.
Yeah. Okay, we have one last question. Should we back up state files as a recovery mechanism in case of corruption?
That's a good one. I have not done that. Well, I've done it at some point when I did something risky, like what I explained before. It does already make a backup when you're working on it. Like if you were quick, you could see it during the session. So it's not really necessary, but of course, yeah, if you, it might be wise to from time to time to have a state, but they need to be up to date as well, because if you have a state file from like a month ago and you made a lot of changes, then that state file is not really that important. And if something really goes wrong, you can always basically recreate, although it takes some time, because all the resources you can import or recreate it at that way. So then you just have to link what is on Azure with the Terraform, and then you're back to your current state again.
Okay.
And also, one thing to add still is tonight we used the free version of Terraform, which is something that you mostly do because it's very powerful. But there's also a paid version, and mostly is Terraform Cloud, which is more like a platform where you can host your state file, work together on a configuration with your teammates. So it has a few of those additional touches for working in the cloud. And then you have more backups and more reliability in that way. So that if you pay for it, that is the things that you get in return for it.
Okay, I did not know that. That's good to know. Okay, thanks. Okay, so that's it for the questions. So thanks everyone for asking all these questions to Frank. Really great.
Yeah,
great.
good questions.
Yeah. So now it is time for our small contest. We waited with this contest after Frank's session, and we did that on purpose, of course. So the question is, what type of infrastructure as code is Terraform? And you can scan the QR code, and this will redirect you to the form where you need to fill in the answer or pick the answer in this case, and fill in a couple of questions that are related to the Build Tech Talks. And then you get a chance of winning that Build hoodie. And I will also post the link in the chat for those that cannot scan the QR code. So fill in that question and win and get a chance of winning that awesome Build hoodie. So for now, this concludes this edition of the Build Tech Talks. And this evening session and all future and past sessions are on our YouTube channel to watch. And if you're interested in more of this, please subscribe to our YouTube channel or our Twitch channel. We are also broadcasting to Twitch. And you can sign up to our Capgemini digital meetup channel as well to get notified when there are new events scheduled. So that's it for now. Our next Build Tech Talk will be on March 15. And this one will be about the ins and outs of web components. So thank you all for watching again, and hopefully till next time. Bye-bye.